So the main reason why they came up with IP version 6 is because uh, if we were to look into the internet infrastructure nowadays, they're running out of IP version 4. Take note that IP version 4 is ranging only from 0 to 255. With that, there are limited combinations. 4 billions roughly, okay? Uh, those are all that are the only combinations that the IP version 4 address has. And nowadays, it's not enough. So that's why they came up with IP version 6. IP version 6 has more. See, very that's ve- that's more. Oh, the more word is okay. So more combination. Okay, like around and undecillion. Okay, like IP version 4 only has billion, so there's trillion, no, gazillion. Not sure about the gazillion, ano, but undecillion. That's how many IP version 6 uh, has. Okay, um, there. Okay, that's the main reason why they came up with IP version 6. So as an overview of the IPv6 is, first it was developed by IATF. Another is, again as I mentioned, there are more space, there are more combinations that the IPv6 has, all because it has 128 bits. Okay, not like with IP version 4 which only has 32. It has improved the packet handling. There are the header, the added informations are simpler. Okay, few in IPv6 as compared to IP version 4. Another, there's no NAT in IPv6. Okay? The good thing with like this, with having no NAT in IPv6 is like this. Example like in Mapua Makati. Okay, Mapua Makati. Our computer in Mapua Makati, the laboratory computers we have there, what is set up there is a private IP. Okay, a private IP. And when we connect in the internet, we need to have a public IP. And with those 1,000 computers we have there in Mapua Makati, our public IP is uh, limited. Say, example, let's say we only have, this is not the exact, ano, but let's say for those 1,000 computers, there's like, say, 200 public IPs. Okay? So we are to share public IPs. We need this public IP if we want to connect to Yahoo, to Google, to Cisco.net, Acad.com. Okay? So there's only a limited public IPs out there. So um, so the way it works is you need to uh, set up the NAT to translate the private to the assigned or shared public IP. Okay, that's for the IP version 4. You will have a much clearer picture of how it works again in the next chapter, next discussions. In IPv6, there's no NAT. Each computer in Mapua Makati has their own public IP. Okay? So that's much better. Imagine sample, let's say, in Mapua Makati, you have your own toilet, right? You have your own toilet. That's much better, right? That's much better because you don't need to fall in line. Okay? Queuing is lessened with that kind of a setup. Okay? In IP version 4, public IP is being shared, like a shared public toilet. So everyone's using it, you need to fall in line. In IP version 6, each of the user or computer has their own public toilet or public IP V6 address. And in effect, it contributes on sending the packet faster. Okay. So here, in my diagram here, there's only 4 billions of IP version 4 addresses in its combination, while in IPv6 there are around 340 undecillion combinations. So this is the specific header in IPv6. We have yung version, which indicates the version 6, traffic class, flow label, payload length, next header hop limit. Very important is the IPv6 address, source, and destination. I Okay, there. So next is all about overview of routing. Okay, all about this time all about routing. Okay, first thing to take note is The moment that, say, a PC1, example like in this diagram I have here, PC1 will send data, okay, this, say this one, um, this packet is again always created here in PC1 on the source, okay, and then PC1 will encapsulate this packet with, like in this case, in the network layer, an IP address, source and destination IP ad. And then once it is encapsulated, what the operating system will do is it will check its own routing table. Each device has its own routing table. Okay. It is in the routing table. There's that very important word here, routing table. In this, it's like a table. Table is like not the table that where we eat, but a table like in Excel. So it has a list of addresses that it identify or recognize. Okay. So usually, let's say in that routing table, PC1 can identify those computers within the network. So for example, this is intended to PC2, okay? I just write 2. So it is intended to PC2. Okay, so um, it will check the routing table, its own routing table. It will identify that PC2 is on the same network, so it will be forwarded to the switch. Switch will forward that to PC2. Okay. Let's say the this time data is to be forwarded to a remote host. Okay, say R. Okay, R. If you notice, say there's a cloud here, meaning let's say for example, this is has something to do with internet. Internet. Okay. Uh, a local network like this one with the PC1 and PC2, those networks that are in the internet is unknown. Unknown. Again, unknown meaning hindi kilala. Unknown to this local network here. To this 192.168.10.0 network. Okay. Uh, Computers checking its routing table has a means to process that. And in the process, what it will do is, if it is unknown, okay, hindi kilala, what the P computer will do is to forward it on the router. It will be forwarded to R1, and R1 will be the one to take charge in processing that unknown packet. That packet that is to be forwarded to this remote host. Okay? There. Another things to take note, uh, we have this IP ad 127001. Okay? It's a very special IP address. Um, Very na special pa. Anyways, it's we call as loopback. Loopback. Okay? The use of the loopback is it is used to test TCP/IP stack. Okay? I'll just write it by hand there. Loopback. So again, it's used to test TCP/IP stack. When you will be on your database, say you will explore PHP SQL, you'll work with forms, and then you have this SQL database localhost. So with the form connecting it to a database, um, so there are two components. There are two pages, two different pages. You want to connect the two of them. Your form, client side or front end, connecting to the database, back end. Uh, it uses TCP/IP component, and the IP address is that 127.0.0.1. Okay, loopback. Okay. Other terms, again, local host is destination is on the same LAN, and then remote host, if they are not on the same network, example like this remote host is on the internet, we call it as a remote host. I even had an example of this in the topology. And then the default gateway. Okay. Again, if we are to set up default gateway in our computer, okay, example this one, PC1, we've learned during our previous discussion that the default gateway of PC1 is the router to where this PC1 is connected. Specifically, the IP address of its LAN interface. Like example like this one. Say that is a G, let's say that is a G0/1 interface. Okay? So whatever IP addresses this G01 has, that is the default gateway of PC1. By concept, default gateway is unknown packets, unknown, okay? Those that are not known or unknown to PC1 are forwarded to DG01. Example, PC1. PC1 type yahoo.com, okay? Again, PC1, it type yahoo.com in the browser, yahoo, say yahoo.com, there. Take note that Yahoo, it's not even an IP ad. And we mentioned before that the computer, what it processes are in the form of an IP. So definitely, this request, this yahoo.com request to be forwarded to our network, it is unknown. Hindi kilala. Unknown to PC1. So what PC1 will do, uh, by default is to drop. It will be dropped, ignored, rejected, drop, unless there is a default gateway. If there is a default gateway set to PC1, what PC1 will do is to forward it to the default gateway. So router will receive this, router will receive that, and since router is the one connected to the internet, okay, diba yahoo.com is that's for the it needs to go to the internet infrastructure. So, router also has a setup to forward that to the internet. That's how it is. Okay. So again, um, PC1, you type Yahoo, that is unknown. Uh, so in a way, it will not be dropped. You need to set up default gateway to PC1. We've discussed that in chapter 2. And then, if there is a default gateway, it will be forwarded to the default gateway, which is the router. And router has a setup to forward that to the internet. That's how it is. I mentioned about a while ago about the that each end device has a routing table. Okay, a host routing table. The command for us to see the routing table in our end device is netstat -r. Okay, there. Example, very important parts here is example this one, no? The 000, this is, it points to the default gateway. This here, this part here, represents unknown packets. But in the previous slide, I mentioned that unknown packets, yahoo.com, google.com, it is to be forwarded to the default gateway. Okay, that's how it is. Also, we present in the routing table the loopback IP and then the local network. Okay, there. Um, there is a separate routing table for IPv6. Okay, so this one, the one that I just explained, it's a IP version for host routing table.